I'm an idiot. Haha. Yes, so 5 minutes has been completely lost. See? So eager to give this talk. I've been on mute for 5 minutes. So I'm going to have to do a voiceover on that video afterwards. Oh dear. Okay, let's start with a common understanding. When I've seen teams take on Docker for the first time, I've seen some confusion around some of the language that's used to describe parts of Docker. So I've always found it helpful to sit down with people and go through those terms and make sure we've got a common understanding so that the rest of the conversation makes sense. So there's two key terms that are used with Docker, container and images. Can you tell me the difference between them? Can you tell me what they are? Anyone?
Is image what's used to sort of populate multiple containers for your purposes?
Okay, an image is used to populate multiple containers. How about everybody else?
So the container is the server and the image is the code.
Container as a server, image is the code, okay.
Not quite.
Okay. Anyone want to follow that one?
The container is part of the Linux virtualization.
Okay.
Thing. Then the image is the image of the disk.
Right.
Thing.
Okay. Close? You're all close. So an image, all it is it's a blueprint that's been built. We've said we want all these things when our container runs, and we've gone and built those things and packaged them up into an image. That's what an image is. It's like a VBox file for those of you who are Vagrant and VirtualBox, and you have to download virtual machine images to get started. It's very similar to that. The blueprint itself, that's what the Dockerfile is. If any of you have ever used Docker, and there's normally a Dockerfile that says how to build an image, that's what the Dockerfile is. It's the blueprint and it builds an image, not a container. When you run an image, what actually happens is Docker creates a container with its own ID, and that's what runs. So a bit similar to what you said about the idea with the container is what runs and the image is the code. A bit similar to that. And you're absolutely right. The underlying technology that makes all this possible is the containerization APIs that exist in the Linux kernel. But that's what we're talking about with containers and images with Docker. Now, the nice thing about containers is you can have one image and you can run multiple copies of them in parallel. So you can scale up and scale out just fine with them. So that's images and containers, and that's all we really need to know about them at this stage to understand what they are. You don't run an image, you build an image and you run a container. Okay? And when you run the container, it's running from the code inside the image. Now there's a couple of properties about each of these that are important for when you're containerizing an application. So we're going to go back to some basics here, some first principles. I'm a big believer in that. I've been doing this a long time, and in my experience, if you know how something's intended to be used, you just avoid a whole class of problems. If you go on Twitter and follow people and watch when they first get involved with Docker, you'll see that inevitably they hit a bit of a brick wall. It's a bit hard at first, but if you take a step back and learn, well, actually, what is this? How does it work? And then approach it from those point of view, you'll find you don't have problems. It's like people in Git. How many people have run into all sorts of problems with Git? Yeah? But if you take a step back and look at how Git's meant to be used and approach it in that point of view, you can use Git trouble-free for years. You really can. So images first. There's two particular properties I want to highlight. The first of all is that you can actually distribute images. And the second thing is that images are built on top of other images. They're like sedimentary rock where you lay down layers. So let's tackle distribution first. So an image is a thing that you can distribute. I could build an image, I could send it to any of you, you could run a container from that image. Okay? It's a form of packaging. In many ways, one of the things that Docker has done is replaced people packaging stuff using the operating system's native packaging. How many of you could package something for the operating system you run today? Yeah? Maybe. Not a lot of confidence. Yeah? There was once a time I could have done that. Not anymore. Those skills have gone. I haven't used them for years. And that's that is one of the nice things about Docker. I can build an image and distribute it to my colleagues or to any of you, and you can run it, and you'll get the same thing. And we can distribute it via places like Docker Hub, where you can get public images. And I believe you can pay them money to so you can have private images as well, where you're building something that you don't want the rest of the world to see. And I know you can set these up on Amazon, on AWS, and I'm sure you can even run it on your own infrastructure if you wanted to. So why is distribution relevant for containerizing applications? When Docker first came out, this was one of the bandwagons everybody jumped on. Everyone got excited about this because we could take the same thing and use it everywhere. I don't know if you're aware, but differences between dev, test, and live can often be the cause of a lot of bugs and a lot of QA problems that get into production. So this seemed like a holy grail to everybody when things first started. Problem is you don't want it in reality. You think you do, but you actually don't. We don't want the same behavior in dev, test, and live. What we want is the same software in dev, test, and live, but we do want some differences. Can anyone guess what those differences might be? Error logging, okay, yeah. Config. Anything particular about the config that might be different? Memory constraints, okay.
Number of instances.
Number of instances, okay.
Where you're connecting to.
Right, where you're connecting to. Anything else from anybody?
Things like
Debug tools, profiling, yeah, these are all good stuff. Any more?
a lot of similarity you want between each one is software that isn't yours. Basically, that someone else's kind of responsibility, and unless you're testing, they've upgraded their libraries, and okay, then it's essentially the stuff which isn't yours.
Okay.
Easily deployable and recreatable.
Right.
But your own software will rerun different versions, guaranteed.
I wish I had a slide for that because that is an excellent point. I don't have a slide for that, but that is an excellent point about wanting software that you haven't built, that you've pulled in from elsewhere, to be the same everywhere, because that's what you're standardizing your app around. That's an excellent point. But what I was looking for was the fact that in development, in all of our businesses, if you're working in a tech business, you are the overhead. You are the cost until AI replaces all of us. So we want our dev images to allow us to work at the best of our abilities and the fastest we possibly can. But once we start shipping stuff to other people, we want those standardized and the same. What we test is what we want to put live. So we want those to be the same. Because otherwise your tests are not 100% meaningful. It undermines some of your testing. So some of the differences in my environments, first of all, is definitely logging. I don't use Xdebug as a debugger at all, because you can't run Xdebug in production. So I load my apps with a lot of logging to tell me what's going on and why. So when there's a problem, I can see what has happened. But I want different logging in dev, where I'm often running with full debug, to live, where often it's only logging if there's a crash or something, for example. Profile debugging tools. I write code that's where performance is important. So I'm using Tideways at the minute, which is a commercial profiler. Obviously, you've got XHProf, you've got Xdebug profiling capabilities as well. In my dev environment, I want those loaded, but there is an overhead to having those even installed, even if they're not being used. So I want rid of them entirely in test and live, especially as they also phone home. And I don't want my live environment making connections out to the internet. I want traffic coming in, but they're behind firewalls. I don't want them trying to go out in the first place. So it's easier just to rip all that out in my production images. Op cache. When I edit in code and I save code in my editor, and then I go to run my app with my browser or run a test tool, I want that code to be picked up and executed straight away. I don't want to have to wait. If I'm having to wait, that's more overhead. So in dev, I want op cache caching not very aggressively. But once I ship the code, that code's not meant to change at all. If I need to change the code, I'm going to build and ship another image. I'm not going to log on the server and change that code anymore. Used to many years ago, freely admit, we've all done it. But I'm just going to build and ship another container instead, another image. So in those images, that op cache is caching as aggressively as possible. I mentioned about saving my app in my dev tool of choice. Those tools expect to have full access to your code. They're written as if the code's always going to be on your host computer, your laptop or your desktop. So if that code's inside your image, if that's where it lives, those tools either can't see that code completely or can't see it and make the full advantage of it. They're starting to do uploads, downloads, round tripping and all that. And where those tools can do that, but it's more overhead, it's slower. So in dev, I sideload the code into Docker rather than bake it into the image. I only bake it in when I'm going to ship the image out to test and prod. So that for me is a huge thing. And it's one of the reasons why distribution impacts how you design your containers when you containerize an app. All right, so far? What do you think? Anything there you go, that doesn't seem right or anything?
I didn't realise that you had to. So if I wanted to release a new version of my code,
Yeah.
that I would ship an entirely new image.
Why not?
I don't know.
Okay.
I never realised. That's something I'd never
Okay.
kind of thought about. I mean, I've not
Yeah.
used Docker before.
Okay.
But that's quite interesting. I should that doesn't really have any negative side effects.
The only negative side effect is the size of the image and distributing it. Now Docker, because Docker's layered, and we're about to get into layers next, Docker only downloads the layers that have changed. It does mean your base operating system, like you're deploying the latest Ubuntu security updates, you end up downloading a lot more stuff. But if you're just changing one of the top layers, like your app or something, you download a lot less. Okay? Those downloads can still be big. I'm not going to pretend otherwise. And it's one reason why people use things like Alpine Linux instead, which is tiny compared to Ubuntu. But it's tiny because it behaves differently. It doesn't use the standard libc, for example. And if you're not using it all day, every day, those differences can catch you out and surprise you. But we'll talk about that more when we get to the operating system section.
You mentioned slide loading. Are you going to go into that?
Definitely are. I'm going to show you how to do that. Got some slides for that. Okay. The second property I want to talk about, and we've just started it really, is the fact that images are layered. They're not big monoliths. They look like it, and they bloody well feel like it when you're waiting for one to deploy, I'll be honest, but they're not. They're layered. It's just like sedimentary rock laid down. If you look inside any Docker file, near the top of the file, you'll find this statement, a from statement. And that's telling Docker, download this pre-existing image, and now everything else in my Dockerfile is going to build on top of that image. We're going to add new layers to it. Okay? And that means we don't have to build one big monolithic image. We can have several images for different purposes, for different specializations. We can have our base layers being nice and general, so we've got lots of flexibility. And as we get closer and closer to what we want to ship, I'll show you that. We'll do a worked example later to show you that. We get more and more specialist in what's going into that image and how it's configured, etc. So that's layering. There isn't much more to say about that at the moment. There's a worked example later on which will hopefully make it clearer. Okay? So moving on to containers. There's 4 properties of containers you need to know about if you want to containerize your app. First one's co-location, what you run inside a single container. The second one is non-persistence, what you lose when your container goes away. Spoiler alert, you lose everything. You lose absolutely everything, so you've got to be careful with that. Then there's customization. It's not obvious when you first start using containers and start running them, but they can customize themselves on startup, and we'll show you more about that. And finally, you need to know about the file system that's inside the container when your code's running. It's not the same that you're running on your host computer. And it has some different properties and some different caveats. You need to know about those. Okay? So let's start with co-location. What do you think you can run inside a Docker container? Or what have you heard about people running inside a Docker container?
Everything?
Everything? Okay.
Feels like a QI trick question.
It's not.
There's a big klaxon that's going to go off.
Not quite.
My understanding is that you should probably run one thing.
Run one thing. Okay.
Like you could run.
Yeah. Yeah, you can run more things. I mean, you're absolutely right. You can run just about anything you choose. There is a sandboxing element to containers, but because I write back office systems and servers, I'm not writing desktop stuff. I'm not hitting device drivers or anything like that. I don't know what those limitations are or aren't for what the sandbox is. So that's why the almost, just in case there's things people want to do. I mean, I don't know if you can run, for example, I don't know if you can run a full X server without jumping through some hoops, for example, a full desktop. But you can also run as many things as you want. And this is the whole thing about co-location. If you want to run multiple processors inside a single container, you can and you should. And when we get to the worked example later on, I'm going to show you, we're going to do a deep dive into co-location. I'm going to show you why co-location is a good idea. And I'll also show you why the traditional advice that you should run one thing and only one thing at a time inside a container is not good advice. And we'll do that in a deep dive in a bit. Second property is non-persistence. I'm old enough to have programmed on punch card, and when I saw this image when I was hunting for slides, it reminded me of that. So I don't remember it being on rolls or anything. I remember it being a flat stack of cards we popped into a hopper, but yeah. That took me back to, admittedly it was my childhood, I hadn't done it professionally. But I can remember some of the computers we grew up with did that, and they weren't ASCII either. Pre-ASCII days as well. So yeah, definitely feeling my age when I saw that one. They're fine until you drop them. Especially if you've forgotten to put the sequence number in the corner, which is there for when you drop them. Oh dear. So persistence is a term you're probably all familiar with. And in container terms, it's what happens when your container goes away. So the thing is, containers go away all the time. If you use Docker commands at all, you'll be aware that you can run a container and you can stop it. And you can also delete it using the rm command. I don't know if you know about that. There's two different sets of commands there. And Docker, I think, could make this a lot clearer in their documentation, a bit like the difference between images and containers. They could make that a bit more clearer for people when they first start out. But it's normal for containers to go away. I use Docker Compose to run my dev environment because I'm running anything up to a dozen containers at a time on a virtual network on my laptop. And it will happily destroy a Docker container and recreate it randomly without me asking it to. I don't know if it's a bug, I don't know if it's a feature. You just design for it. But when you upload containers to the cloud and to orchestration systems, they're also designed with this property in mind, that containers will go away. Because if you're running a pool of 5 and then you've got a surge of traffic and they go up to, say, 10, for example, and then they've got to go back down to 5 when that big spike has gone away, it has to destroy those other 5 containers. It's not going to leave them lying around. So containers going away is normal. And this is something everyone learns the hard way. When a container is gone, everything inside it is gone completely. So the contents of a container aren't persistent. Anything you save inside your container is deleted. If you take one thing away from this talk, if you tweet one slide, this is so important, I've given it a red background. I know we're having a laugh about it here, but I've seen every team who's tried to containerize apps go through this the hard way, not realizing the difference, because they're so used to virtual machines, and you don't, I've got a virtual machine that's probably 7 or 8 years old. I've keep upgrading Ubuntu on it. I've never destroyed it and recreated it from scratch. That's normal with virtual machines, especially dev environments. But with Docker, they're much more, I'm trying to think of the right word.
Transient?
Transient maybe is a good word, yeah.
Ephemeral.
Ephemeral, that is the word I was looking for. Thank you very much, ephemeral. They're much more ephemeral.
That's kind of like AWS language, isn't it, almost?
Yeah.
Like AWS, but I think I've kind of more grown up in like these sort of, not grown up, but when I've got into this kind of stuff, it's been more AWS or Google App Engine. This is kind of baked in a bit more. They say, we're going to be upgrading this left, right and centre. Don't trust data stored on this, but use our database systems if you want to store stuff.
Same idea with Docker. Difference is there is no database system unless you provide your own, okay? Or unless you're running in a cloud system that's providing them. And that's why this slide. If you treat your containers like they're just a virtual machine, and you've got your containers saving data inside them, and sort of putting databases inside them, I've seen people do that, and then your container goes away, you lose everything. So, can we put together a list of what persistent data we might lose when your container goes away? What would you think?
Log files?
Log files, that's a good one. Cache, what kind of cache? Okay. Shouldn't a cache be temporary though? I think if you're a Symfony developer, you're forced to rely on a permanent cache,
Yeah.
but that's a different thing.
Yeah, it's some cache should be, but sometimes there's reasons to.
Okay. All right. Anybody else?
Relational databases.
Relational databases, absolutely.
Non-relational databases.
Sorry?
Non-relational databases.
Okay. Any sort of database. Any sort of database, okay. Anything else?
Uploaded file.
Uploaded files is a good one.
Sessions.
Sessions, that's also a good one. Okay. And we've got most of these on the next slide. So databases, absolutely. File uploads, absolutely. Session data, absolutely. Last thing you want is your user being randomly logged out because your container's gone away, for example. I think it's awesome that WordPress does auto upgrades, and it has admin panels where people can download and install plugins without needing access to the server or knowing how to log into a server. I think that's awesome for letting people put more content on the web. But WordPress is doing, if you're running WordPress inside a container, it's installing all these things into the container. Excuse me. And I imagine its competitors work in pretty much the same way. So, but I don't know if you're aware, not only going to lose the files, but when WordPress upgrades and when plugins install and auto upgrade, they can change the database schema. So you've lost your container, you've lost your upgrades, you fire up your container with the old code in. How's that going to work? It's now talking to a database with a slightly different database schema. I wouldn't like to bet that you could recover from that 100% of the time. It'd be nice if you could just drop the upgrades back on and away you go, but you may not be able to. So it's something to be aware of. And logs, as was mentioned before as well, very important.
Is it really a case it's WordPress and you don't never do it Docker?
Oh, you can. I run WordPress in a Docker container. And the reason, how we get around it is we can actually inject volumes into our container at runtime. Persistent places that are safe to write, a bit like EBS with Amazon. I haven't used App Engine, so I don't know what the equivalent is.
Yeah, but they extract it away a bit, so you have to use their database.
Right. Okay. The slides will be online, so you'll be able to look at this and see what it is. This is from my Docker Compose file. But you can actually say, here's a folder on the host operating system, and here's where it will appear inside the container when it runs. So the container, the container has places to write to. You have to customize your applications and configure them, to write to those locations. And you decide where it goes. Okay. And we'll talk about this a bit more when we do the worked example. Third property is customization or tailoring. And we've been talking about the fact that Docker containers can write to their file systems. They can change their contents. And one of the nice things about this, there's no reason why it can't change its contents when it starts up. It can rewrite its config files when it boots, when you start a container. Any ideas why we might want to do that?
Environments.
Environments?
Stuff like dev tests and that stuff.
Okay.
Some way of uniquely identifying the container it's executing.
Okay. So unique IDs, although you can, with Docker, if memory serves, you get a unique host name anyway, which is the container ID. If memory serves. I give mine real names, so I've not looked at that for a long time, but I believe it does that. Any other ideas?
Maybe passwords?
Passwords, okay. Okay. So Have you heard of 12-factor applications and the 12-factor app movement?
I could not name, I don't think, a single one of the factors.
Well,
Well,
for today, one of those factors is the idea that you inject credentials and config via environment variables into your web server and into your app. And that's fine if you're using Apache, but if you're using Nginx, Nginx will not use those environment variables. Nginx does not support using environment variables in config files. So this is how I started doing bootstrap scripts for containers. I was realizing, well, I'm running Nginx, but I can't get my config into this file. So I ended up writing a script that would take those environment variables and use those to rewrite the Nginx config file, and then it runs Nginx for me. And that's how I got into that. And I've seen people do this with WordPress, where they'll actually make it down, in your config, you give it a list of plugins that should be installed. It'll go and download them and inject them automatically for you, so that you can give it out to new developers. You say, put this in your Docker Compose file, run Docker Compose, it will start your container, and it will set up the correct environment for each new developer on the team, just like that. Quite clever.
So this is, why would you do that? Well, actually, maybe you're describing the same thing.
Okay.
I'm aware that in a Dockerfile you can enter commands that you run that you execute.
Yes.
Is that what you're talking about?
Not quite.
Different. So why would you do it one way versus the other?
So anything in the Docker file is fixed when you build the image, not when you run the create container. So I can't tailor anything for specific
So
circumstances.
you might that container boot.
Yes, a container boot. Absolutely. Yeah,
Some plugin.
absolutely. So yeah, a one-time startup script. You need to be aware that if you change any of these things that you're injecting into your container, you have to destroy the container, and so Docker will create another one. If you stop the container and just start it up again, chances are your script's not sophisticated enough to rewrite the files a second time and undo the first set of changes. You'll end up destroying your container. And then we're back to persistent data and not losing your data. So it's all linked in. Final properties, copy on write file systems. I couldn't find a demonic cow. It's meant to be here be dragons. But I couldn't find a demonic cow for this section. Now, have any of you used a copy on write file system? Do you know what they are?
So this is when you modify a file and actually correct a copy of it.
A bit like that.
Is this like a read-only file system overlay? Or write? So you've got a read-only file system,
Yep.
write file system overlay.
Yes, correct. Exactly that. And it's actually the number one innovation that made Docker big, was the fact that inside their images, they're using this copy and write file system. When you're laying those layers down, the previous layer becomes read-only, and it's writing a new layer over the top. Conceptually, it's like each layer is like a set of diffs between the previous layer. And that's one of the reasons Docker images can get quite big, because they're not squashed by default. I believe there's now some commands to help you squash that stuff. I don't know much about that, I'll be honest. But that's what Docker does. And when you download a Docker image, you'll see it say downloading, downloading, downloading. You might see 15 or 20 of these, it's downloading. And each of these is a separate layer in the copy on write file system when it's downloading. Now, the thing is with copy on write file systems is they're not as mature as the file system that's touching your SSD or your spinning Rust by any means. They are slow, and if you've got an app that's doing a lot of writes to that file system, you will crash. You'll crash a container, and I have crashed my host computer on more than one occasion with it. These file systems are buggy. I believe Docker, if memory serves, I could be wrong, but I believe Docker are on their third file system trying to sort this out. They started with AUFS, then they went to overlay FS, then they went to overlay 2, and they're still trying to get it right. These things are hard. So the thing is, once you've started up your container and it's done its tailoring, you don't want to be writing to the container's file system if you can avoid it. Some of that will be design, making sure you've got somewhere, these volumes mounted for your app to write to. But you may have to go back to your app and go, well, you can't write anymore. You've got to stop writing to the disk. You may have to change your app for it to run successfully inside a container, for it to run stably. Something to be aware of. So if we take all these principles, we can distill them into 5 key questions that you have to answer whenever you containerize anything new. About how do we break things up into layers, and I'll show you, we're going to do a working example in a minute of that. What does my app need in order to run? Because it hasn't got access. The only thing the container has access to by default is the kernel. Shared kernel, that's one other thing that's different to from virtual machines. It's all sharing the same kernel. You don't put a kernel inside a container. So any libraries that are needed, like libc, etc., have to be loaded into the container. How do you configure everything? And how are you going to customize it? Where's the persistent data going to go? Because otherwise it would be going, gone. So be careful with that. And what else can you do to make sure you're not writing to the container's file system so it doesn't crash? So whenever you're containerizing an app, this is a handy checklist to have. Have you answered all these questions? If you haven't answered all of these, you're going to run into problems, I'm afraid. Okay? You all right so far?